This is group 3. We're doing the ultrasonic wave test. I'm Will, and there are two types of electronic waves. You have electrical and mechanical waves, and a subcategory of mechanical waves. There's longitudinal and transversal. We will be working with transversal today. Our experiments. This is an NDT. Experiment which has ultrasound, magnetic, and radiographic. So we can demonstrate everything. And examples of uses of this can be used in mechanical engineering, forensics, civil, and medicine, and pretty much you can almost use it whatever you want.
I'm Dave. I'm going to be walking us through the procedure of this laboratory. Like I said previously, it's an ultrasound test. It's also non-destructive testing. Pretty much whenever you're testing an object, you don't destroy it, you can actually reuse it again. So for this procedure, we're actually using olive oil as a lubricant, and you take some, you put on the block of whatever you're testing, and this probe is also lubricated and sent over all these holes. So you notice that these holes are really easy to see. We're just going to use this as an example. Holes in real life, they even align like so. You really have to use your head and figure out where one starts and where one ends. Everything is going to be shown on this device, and whenever you go over a hole, you'll see that there's changes. There's a basic to 0 change to an increase of inches or a decrease in inches. So this pretty much plots exactly where you have to go or what's exactly there. This is just for a block that has holes. This one, in real life, ultrasonic test is to actually look through things that we're not able to see physically. That's where we actually start sending sound waves into the metal, have it bounce off an object or a hole or whatever we're looking for, goes into the probe, into the machine, and shows on the display right here. So you'll see that there's no holes here, but there's actually holes. And going over this entire unit, you'll notice, if you're really good at the graphs, some of them actually align. Not only that, but because of this piece of metal, we had to hide all the holes. And because of that, there's there's outliers in the experiment. You just have to know exactly where they are, and what they do.
So Nick, once again with group 3. So I'm just going to be reiterating a couple of what my group's members have said about basically non-destructive and destructive testing. So yeah, one of the main differences between non-destructive and destructive is, of course, when you have destructive material testing, such as a tensile test, the material itself would break, basically unusable again. And this, of course, non-destructive test doesn't have a permanent effect on the testing material. So to wrap it all up, basically, some of the errors that we found in this lab, again, what my lab partner Dave said about here, these holes here drilling in actually lined up with some of the holes here, and when they overlap, basically you get 2 different readings. So that's one error that we had to account for. Another error could be calibrating and understanding the actual machine itself. Basically, you input a value wrong or you read the graph wrong. It could all lead to different results, basically. And another final error would be human error itself, and that would be the measuring of the holes using the ruler. And yeah.